Okay, folks, moving on. So we're up to number 13, but at the top of the page it says we're going to use our calculator. So for infinity, you could use 1 EE99, which is 1 times 10 to the 99th, which is 1 followed by 99 zeros. Or you could do -1 for negative infinity, -1 EE99. But my lazy trick, and what most people do, is instead of typing the 1 EE99, they just put a bunch of 9s. And for negative infinity, instead of -1 EE99, they just put negative and a bunch of 9s, as you shall see in a second. So the standard normal, standard normal. There's many normal distributions, but the standard normal has a mu of 0 and a sigma of 1, a mean and a standard deviation. Technically a population mean and a population standard deviation. Don't get too caught up in those words, just a mean of 0, standard deviation of 1. Okay, problem number 13. Probability that z is less than -2.37. Draw a picture. 0 is in the center. -2.37 is somewhere over there. We want less than. So like that. Okay, so then whenever I'm going to use the calculator, I'm going to use the normal CDF. And how far do I shade on the left side? It goes all the way to negative infinity. So that's why for the lower bound, I'm going to give it -99999. And then the upper bound is going to be -2.37. Mean of 0, standard deviation of 1. So let's try it out over here. It's going to be the distribution, normal CDF. Some of you have fancy calculators where it asks for all 4 explicitly. That's nice. My calculator, not so cool. So I'm going to give it, ooh, careful, there's subtract button and then there's negative button. So -99999, comma, negative, not subtract, -2.37, comma, 0, comma, 1, end parenthesis, enter. Ta-da! So that's going to equal 0.0089. Rounded to the 4th place for no particular reason. Okay, let's do 14. Probability that z is greater than -1.88. Draw a picture. 0 in the middle, so -1.88 is over here. Shaded to the right, greater than. Aha, so my answer better be more than 0.5. Okay, so I'm going to do the calculator. Distribution, normal CDF, enter. And you see now it's going from -1.88 all the way to infinity. So make sure you give it -1.88, comma, infinity. I'm lazy, so I'm just going to put 9, comma, and then 0, comma, 1. Enter. And it gives me an answer of 0.9699. More than 0.5, like I said. Okay. Number 15. Do I have enough on this piece of paper? Sure, 15. 15 says the probability that z is less than 2.96. So if I draw a picture, 2.96 is way over here on the right side, shading to the left. Okay. So that means my lower bound is infinity, upper bound 2.96. So, distribution, normal CDF, lower bound, -9999999, comma, 2.96, comma, 0, comma, 1, and parenthesis, enter. And we get an answer of 0.9985 when I round to the 4th place for no particular reason, other than we've been doing that all day. Okay. Moving on to problem number 16. Whew, this is tiring. 16. Probability that z is greater than 3.11. picture. 0's in the middle. The positive 3.11 is way out here. Which way do I shade? To the right, right tail. Okay, so my lower bound is 3.11. My upper bound is infinity. So, distribution, normal CDF, enter, lower bound 3.11, comma, upper bound 9999999, comma, 0, comma, 1, and parenthesis, enter. Ooh, so not much shaded. It's 9.355 E negative 4. So it's about 9.355 times 10 to the negative 4, which is 0.123935. Aha! Good thing we studied scientific notation. Let's see, number 17. Oh, betweens. Oh, betweens are easy. 17. Notice how they do a between problem. It's weird because you don't really read it exactly from left to right. So I don't say probability that negative 2 less than z less than 1. You could, but it's just clunky. What you'd say is the probability that z is between negative 2 and 1. Oh, okay, yeah, that sounds better. And notice that it's always going to be less than symbols. Always? Always. Okay, so between, it always uses less than symbols, and the smaller number on the left, the bigger on the right. So this one's super easy. So since it's a between, that's just our lower bound and upper bound. So if I draw a picture, negative 2, 1, and everything between. So the lower bound is negative 2, the upper bound is 1. So you just go to distribution, normal CDF. I'll make sure the negative 2, comma, 1, comma, 0, comma, 1. Enter. That area is 0.8186 about. So that's our answer, 0.8186. Whew. Okay. Another one? I mean, yay, another one. 18. Going through paper like there's no mañana. 18. Probability that z is between negative 1.45 and negative 0.08. And it's just a between problem. Between problems are easy, so I'll just throw it in my calculator. I'm so fancy at this point, I don't need to draw a picture. You should draw a picture, though. Okay, distribution, normal CDF, enter, negative 1.45, comma, negative 0.08, don't lose that 0, comma, 0, comma, 1, enter, 0.3946, rounded to the 4th place. Okay, number 19, the never-ending statistics video. Okay, so now they want us to play the game backwards. So if you're playing the game backwards in math, it's called inverse. So in number 19, they talk about number 19 is the 99th percentile. 99th percentile, so we write that as P sub 99. So that means, like let's say you took a standardized test and you scored at the 99th percentile, that means you did really good. You did better than 99% of the people who took it. So if we drew a picture of it, you did better than 99% of the people who took it. You did way up here. You did really good. So the question is, what's the z value that corresponds to that 99% on the left? So percentiles are all about left tails. Okay, so left tails, our calculator is designed for left tails, so that shouldn't be too crazy. And we're playing the game backwards, it's inverse. So let's go to our distribution, and you'll see that it says inverse normal. Okay, inverse normal, and we need to give it an area, a mu, and a sigma. So the area, 0.99, comma, the mu, 0, sigma, 1. Enter. So this location is about 2.3, Let's just round it. 2.33, 2.326, 2.33. Okay, so maybe you want to say z is equal to that. So that's the game. We're playing it backwards. So notice in the past, they would give us the z. We would come up with the area. Now, they give us the area. We come up with the z. Okay, I get the game. Playing it backwards. So 20 is p sub 65. P sub 65. Okay. So that means there's 65% on the left side. So we're just going to do the inverse normal. So let's see, second distribution, inverse normal, 0.65, comma, mean of 0, comma, standard deviation of 1. Enter. So z value of 0.385339 z. So you might be confused, why did I round to 2 as opposed, why didn't I go 4? So when we get z values, we usually round to 2 or 3. But the areas, we usually go to 4. Ugh, confusing. Okay. 21. Oh, the z's. So notice the p, it's all about left tail on the left. The z's are on the right. So if it says z of 0.05, that means they want 5% on the right side. Well, my calculator doesn't think in terms of right tails, it does left tails. So what should I put? How can I trick my calculator into giving me the right answer? I'm going to do an inverse norm of what area? 1 minus that. Oh, I see what you did. Keep doing that 1 minus trick. Yes. Yes, I do. Okay, so distribution, inverse norm, 0.95, comma, 0, comma, 1. Enter. So this location right here is at z equals 1.645. Well, why did you go 3 places that time? You went 2 there. Ugh, I know, confusing. Turns out 5% on the left or right tail is really popular, so we go that extra 3rd place. OMG, OMG, OMG. I know, confusing. 22. Z of 0.025. So we're going to put 0.025 on the right side because it's z, so 0.025 on the right. Okay, we're looking for the z value that corresponds to that. Oh, so it's just like what we did before. So instead of, so what should I put there? So distribution, inverse norm, area, don't put 0.025, put 1 minus that. So 0.975, comma, 0, comma, 1, right? You agree with me that 1 minus 0.025 is equal to 0.975? Yes. Good. Enter. And that gives us a z value of 1.96. Aha. And then I went 2 places. Yes. Whew. What was that? Number 22. 14 minutes in. Okay. Oh my God. Okay. We'll do 23, 24, and then we'll take a little break. 23. Middle, 90%. Okay, middle 90%. Let's draw a picture. Put 90% in the middle. How much is left over? 10%. Okay, so how much here? How much here? So that's 5% on the left, 5% on the right. Okay, cool. Do you believe in the symmetry of the bell curve? Yes. Okay, so all we really need to do is figure out this one, and we automatically get that one. We're trying to find the z that corresponds to the 5% on the left. Remember, a calculator can handle left tails. So let's figure out 5% on the left. So inverse norm. What the? Distribution. Inverse norm. Let's put 0.05, 5%, comma, 0, comma, 1. Oh, that's that 1.645 thingy, so that's negative 1.645. And so if you believe in the symmetry of the bell curve, the answer right here must be positive 1.645. So they're looking for the z's that correspond to the middle 90%. So our answer, you could say, is plus or minus. You quote that symbol, plus or minus 1.645. Yay. 24 wants the middle 95%. Okay, same approach, draw a picture, put 95% in the center. How much is left over? 5%. Okay, chop it in half, some here, some there. 5% chopped in half. So 2.5% here, 2.5% here. 2.5% is a decimal, 0.025. This is the left tail, so our calculator can handle it. Let's do inverse norm. Enter 0.025, comma, 0, comma, 1, and parenthesis, enter. Oh, it's that 1.96, so negative 1.96. For that z value, do you believe in the symmetry of the bell curve? Yes, good, positive 1.96. So z is equal to plus or minus 1.96. Oh my, okay, let's pause there, and then I'll take a little break and start the next video. Fun, 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 folks, fun, fun, fun.